Hello and welcome to another edition of Momentum. I'm your host, John Mercado. Our guests today are Daniel Coates and Aaron Hale, seniors in electrical and computer engineering here at Mississippi State University. And they're here to talk about their senior design project with us today. Thanks for being on the show.
Thanks for having us.
Thank you for having us.
So the place I'd like to start is just with senior design as a course. What's involved in a senior design course in ECE?
So senior design is an accumulation of all the classes that have been taught in the ECE department up until that point, and it allows students to figure out a project they want to do and how they're going to implement it. They're given a little bit of free reign on how they want to do it. They're given like certain restrictions on what they can and can't do with their project, but it allows them to just build on the foundation that they've already learned and just make something that hasn't been done before.
Okay. And as I understand it, the goal of the class ultimately is to develop a working prototype by the end of the semester. Is that correct?
Correct.
Right.
Yeah.
So all of that knowledge comes to bear on the prototype.
Mm-hmm.
And you had, how much freedom did you have in terms of a project? Were you assigned the project? Did you come up with it yourself? Where'd you come up with the idea?
So you come up with a project and you come to Dr. Jones and you propose it. And he decides whether it's appropriate or not for the class. And we actually came up with about 2-3 of the projects and they got turned down. So we went to a faculty member here at Mississippi State and he had the project idea and decided that would be good for us to do.
Okay. And so tell us about that project itself. What exactly are you guys working on?
We're working on a automated solar panel cleaner. We call it the SPAC, a solar powered automated cleaner. And it just allows a homeowner to be able to put a device on their rooftops if they have solar panels there, use app capabilities to turn it on, let the device run and clean their panels for them so they don't have to do it themselves.
Okay. And what's the motivation or market for this? I mean, why would somebody need a device like this, or why would they want a device like this?
Because the efficiency of the solar panel, it greatly deteriorates if it's really dirty. And the flatter the solar panel is, the more accumulation, because most solar panels are at an angle, rain can kind of wash them off, but with flatter ones you actually do have to keep pretty clean.
Okay. So that accumulated dirt or any kind of, I guess, residue, how much of an effect does that have in terms of efficiency? Do you know?
Well, solar panels in themselves don't operate at a very high efficiency rate. Like the ones right now that are coming out, they're being more and more efficient. They're only topping out at about 25% efficiency rate.
Wow.
So when the grime and stuff gets on it, it lowers that efficiency rate down to 15% or so, which is a really large drop when you put it in perspective. So using this device, it lets them clean it up and utilize the most they can with their solar panels.
And I imagine the answer to this may be obvious, but just to make sure we get it out there, what are the drawbacks with manual cleaning or hiring somebody to do it?
Hiring is really expensive.
Okay.
It's in the hundreds of dollars to get somebody, thousands of dollars depending on how many solar panels you have. And a lot of them are on rooftops and stuff, so doing it yourself is pretty dangerous, and this would allow you to just sit inside your house comfortably, let it clean them for you.
I imagine manually it's time consuming too, in addition to whatever dangers might be there. It's inefficient in terms of time. As far as a market goes, are there a lot of solar panel operated homes in the South, or how widespread is that? I know that in some of my travels I've seen them in other places. I don't know that I've seen too many in the South. So I guess the broader question is just like, what's the market for this product?
Yeah, solar panels are becoming more and more popular in homes today, and it's not so much to completely have them solar powered, but just to let them have lowering their utility bills. And so that's why more and more people are getting solar panels, and solar panels in themselves are pretty expensive. So a homeowner buying one has to justify that they're going to be able to make a profit down the line. And so using our device will help them bring back that profit quicker.
Okay. And so is this something that could be used, say, out in the Southwest where there are more solar panels because there's a lot more sun? Is that something you've thought about, or is that not quite part of the picture yet?
Not quite part of the picture. Big solar farms, you would have to have a lot of battery life or have maybe its own solar panel so that it can continue on.
Yeah.
But so it's mostly for home use.
I see. Okay. Well, we're going to take a short break and then we'll come back and talk about your prototype itself. So We'll be right back.
What drives you? What pushes you forward? Is it an appetite to be the best or a calling to make a difference? For those of us here at Mississippi State University, it's both. We're designing a future where cutting-edge hybrid technology isn't imported from overseas, but exported from our own backyard. We're working toward a day when solutions to energy independence move at 0 to 60 in 5.5 seconds and are as simple as charging a phone. A day when fuel economy and environmentally friendly are viewed as less of a compromise and look more like this. For us, turning heads in the auto industry is great, but living up to the hype is even better. That's because it's about more than simply envisioning the future. It's about getting there. And here at Mississippi State, we know just the ride to take. When you're the best, everyone wants to see what you'll do next. At Mississippi State University, our team of world-class rocket engineers is venturing beyond boundaries, building rockets like none before. We're launching a new era of space exploration. We've developed cutting-edge technology that's helping us build a rocket that can travel at 4 times the speed of sound. Fast? Yes. But more importantly, revolutionary. For you and for a space program that produces many of the conveniences we enjoy today. We're shaping your life in ways you never dreamed. What's next? Watch us and see. Imagine a helmet so protective that it transforms the safety of the game. We are at Mississippi State University, where we ring true.
Welcome back. We're here with Daniel Coates and Aaron Hale, senior ECE majors, talking about their design project, the SPAC. And we're going to turn our attention now to the prototype, the device they've actually put together as part of Senior Design 1. So, guys, tell us about this contraption here.
Well, so basically you have a couple of components. You want to have the front end, that the sponge isn't actually on it, but it actually is what's cleaning the solar panel. The back end, you have a squeegee, so that you're squeegeeing the dirty stuff down as you're cleaning, and the water pump that's actually putting the solution on there to clean it.
Okay. And how does it know to stay on the solar panel? I mean, what keeps it from falling off?
That's actually some pretty engineering ingenuity we put in there. Aaron figured out that we needed 2 different types of sensors on the sides, so that way they can determine where an edge is at. If you think about a Roomba detects edges by feeling something. We detect edges by not seeing anything. And so having those sensors on there helps back know, hey, there's an edge, or hey, I'm on the roof.
Okay. And you said there's 2 types of sensors. Can you give us kind of a thumbnail sketch of the difference between those?
So the ultrasonic sensor sends out a signal and receives it, so you get a distance. Allows you to know exactly how far away you are. The IR sensors solely look for the light beaming back at it. So it's either on or off really quick. That was the main thing about it. That's why it's on the front, is as soon as you hit that edge, you want to know and stop, back up.
Okay. And then I assume this is the cleaning solution. What is that solution actually?
Right now, it's just water in there.
Okay. All right.
We're working on, in the fall when we get into design 2, maybe implementing some sort of solution that doesn't create soap duds or anything like that, so there's not any foam getting on the solar panels, because that'll be a lot harder to clean off.
Right. Okay. And I got to ask about the lights. The lights look fantastic. Do they perform some function, or is that merely for aesthetic purposes?
Just watching it, I mean, all it does is roam around and clean a solar panel, so it got kind of boring. Just wanted to put a little flair to it.
Yeah, a little nightclub action with the solar panel cleaner. What would you say were the biggest challenges you faced in doing this? Once you started putting things together and making it work, what were sort of the hardest things to overcome?
Some of the biggest difficulties we had was really trying to find a power source that would power all this, and we had to go back many times trying to find a battery pack that would support it. And the battery pack that we have now, it works fine. We just might look into getting something that might be a little more efficient and lasting, or the battery life, being able to perform more runs and sweeps on the solar panel in the future. And
Any problems with the sensors? I mean, as a layperson, that would be one of my fears, is that they weren't going to sense and it would run off the the edge or something.
So the IR sensors actually have a problem with intense light, because then it can't read its light correctly. So during the demo, it became an issue trying to run this thing outside. But the main purpose of it would be at night, because you don't want it to run on your solar panel that's creating deficiency as well.
Right.
So you would want it to just go run at night, so that shouldn't be an issue.
All right. And then Daniel mentioned Design 2. So senior design is a 2-semester course, Design 1 and Design 2. What happens in Design 2?
so the hard part is over. We had to make the prototype. I really shouldn't say that. It's probably going to be difficult this fall. But right now, as you can see, it doesn't look very pretty aside from the lights. And so that's going to be the main project for Design 2, is packaging it up, making it look a little more presentable for a homeowner to use, because nobody's wanting to have something with wires sticking out of it.
Right.
It's also got to be IP rated, so we got to make it waterproof. I mean, it obviously has solution on it. It needs to keep the electronics from getting water and dust and stuff like that.
Okay. And break down IP rated. What is that?
It's just the engineering standard for it's water and dust, like it's particles. So it has a rating to what it can actually take. So like
Okay.
a 1 would be it can take a sprinkle. 5 would be you can splash a bucket of water on it.
Okay. And that's counting the enclosure, the thing you're
yes,
talking about you're going to
correct.
build. Okay. I see. And then what's next beyond that? I mean, do you have some designs on manufacturing this and bringing it to market somehow, or is this pretty much just going to be a prototype for Design 1 and 2?
As of right now, we just got it set for a prototype for Design 1 and Design 2 in case something does happen in the fall and we stroke upon genius and figuring out how we're going to market this a whole lot better than we're thinking about it now. We might stick with it and figure some way out to push it out to the public. But for right now, I think we're just focusing on making it work and making it look right.
Very good. Well, Daniel, Aaron, thank you for being on the show today. It was great to learn about this.
Thank you for having us.
All right, thank you. That's our show for today. Remember, you can follow us on social media via Facebook, Twitter, and Instagram at MSU Engineering. Thank you for being here.